All right, I'm going to go ahead and work through the review for the exam on variation. And looking at the first problem, suppose each employee in a company receives a 10% raise for the year. That means you multiply each employee's salary by 1.10. To get the new standard deviation, you will. So for standard deviations, and I did have a CAMI D review notes, which I'll put a link to in this review. If you multiply or divide the data by a number, you can do the same thing to get the new mean and the new standard deviation. So make that note to yourself when you are doing this question. All right. So here we're going to suppose each employee. That means we're just going to multiply by 1.10, and that should happen. If only the largest value of a data set has 30 added to it, which of the following is false? So maybe the easiest way to look at that, let me go ahead and do one quantitative variable. And we'll just add some data points here. We'll pretend they're quiz grades or something like that, right? Because you guys are used to grade data. And 90, 70, 80, 70. We'll pretend this is the data, right? And then you can see there's a summary statistics and what's going on. So remember, when you're stuck on a problem, you can always say, hey, what would happen if I did this to the data? So if we only add 30 to it, which of the following is false? Does the range increase? Well, it should, all right? So let me actually do two sets of data. That would make it easier. Let me go back. I'm going to copy my data. And I'm going to do two sets of data so we can see it. So here's my original data. And I'm going to take that 90, add 30 to largest data point. So it's the same data, except I added 30 to this largest data point. All right, and begin analysis. So there's my data, and you can see that data point moved up by 30. Now, I can see the mean went up, the standard deviation went up. The range is also how far. An easy way to see that is to look at box plots because it goes from smallest to largest. The range really went up. I'm going to go back to my dot plot. So, did the median stay the same? Probably. Let's go look. Did the median stay the same? Yeah, the median's exactly the same because it's still the middle point. It didn't change. I only changed a high point, which does nothing to the median. And let's see, the mean increases. That makes sense. So let's go check. The mean is now 77.5 to 81.25. And then let's see, I think the other one was does the interquartile range increase? Well, if we look at it, Q1 and Q3 are still the same. So it didn't increase because just adjusting this largest point does nothing to Q3. Q3 is still over here, right? So if I look at my box plots, the box plots for the Q1, Q3, they look kind of funny here. That didn't change at all. So it probably would have been better if I had more data points to make that even better. But you can see the IQR didn't change at all. So that's probably the one that it is. Then let's just go double check standard deviation. Standard deviation did increase, and why is that? Because the typical distance between the data points and the mean, even though the mean went up, adding 30 to this really changed the values, and so it adjusted how much it increases spread. All right, so there's our values right there. Which two of the following summaries are changed by adding 50 to each data value? So variance, anything for spread. Okay, so let's do this. Values for spread. And these including IQR, standard deviation, and range are not affected by adding a constant to each data point. All right, not affected at all. So if we go back and actually let me go to the question. So variance, IQR, the median is affected, the mean is affected, but these other three, they are measures the spread, and so they're not affected. Which of the following summaries are changed by dividing each data value by 4? That should be all of them. And so when you multiply or divide, remember on my review notes here, if you can do the same thing to the new mean and the new standard deviation. This applies to all. This applies to spread, which is, the IQR, standard deviation and range, and location. That's things like mean, median, Q1, Q3. Those are all measures of location, all right? So there you go. So this should affect everything. Let me go back to my question. The mean, the median, the variance, the standard deviation, the IQR, all right? Now, I should make a note. Be careful with, variance is special. So treat variance like a special number. To get it, first find the standard deviation and then square it. All right, so make sure you do that. Okay, so I'll go ahead and submit that. And we got all our points there. All right. John likes to order the all-you-can-eat shrimp in his favorite restaurant. Here are the number of shrimp he ate during his last 5 visits to the restaurant. So here we go. I'm going to go ahead and take those numbers. And what I can do is I can actually paste them into the Stapplet and edit inputs, original. Actually, yeah, that's fine. We'll go back to one group Stapplet. I only have one group of data. There we go. And begin analysis. So we're going to let this Stapplet do a lot of our calculations, which I'm sure you're fine with. All right, so determine the mode. So I've got the mode, the median, and the mean. Well, the mean is 13, the median is 50. 15 median, 13 mean. Okay, so let me go. 15 is the median. I think it said 13 was the mean. And let's go back to the data. Yeah, 13 is the mean. And mode. Mode is the most popular. So in this case, it is 19. So let me go ahead and put the mode as 19. And then variance. You actually remember that note I just made? Let's go get the standard deviation first. Standard deviation. Where are you? Standard deviation. There you are. 6.633. 6.633. That's it. Then go find the variance. So let me pull up a calculator. Which actually I can just use a regular calculator. You don't need a fancy one for this. Oops, it's too big though. All right, let me pull up a TI. Give it a second to come up. Tell you what, while the TI is pulling up for the variance, I'll go ahead and do these others. Q1 is right there. 6 and 19 are Q1 and Q3. Oops, I keep clicking on that. 6 and 19, I think I said. And then IQR, just go 19 minus 6, right? And so let me go ahead and do that variance first. So here's my calculator. Let me kind of see if I can make it smaller. And my variance, my number was 6.663. 633. Let me just go look at the Stapplet. It was 6.633. 6.633. And I'm going to hit the squared button and then hit enter. And you can't see it, but there it is. 43.96689. Now, I had a person who was not doing well on their test, and they were getting the wrong answer, but they were doing the right math. So this is, by the way, for the variance. So I squared this to get the variance. And what happened is they were rounding too much. If you are on Stapplet, it is way better for you to put all the ugly decimals right in there than it is to round. If you put like 43, this would mark it wrong. And 43 would not be rounded correctly anyways. 44 would probably work. It probably would be fine. But usually it's an issue of rounding. So if you are not comfortable with the whole rounding thing, just put in all the decimals. And if it becomes an issue when you're testing, just write down your answer. And if it's a rounding issue, I can override it. Okay, IQR is Q3 minus Q1, and I can pretty much figure that out in my head. 13. 19 minus 6 is 3. Make sure I wrote 6 and 19. Yes, I wrote the correct values. And that should be it for that set of data. So let me go ahead and make sure I have all that data correct. And you can see that all these values are correct. Now, John had 3 friends who went with him, and each ate the same amount of shrimp as John did on the 5 visits. All right. Calculate the new statistics for the total amount of shrimp all friends ate. So let me go ahead. First of all, there are a couple things. There are definitely shortcuts here. You could multiply all these values by 4 and put them in Statlet. But I'm going to tell you, you can also just multiply all these values by 4. So I can just go 19 times 4. What is that? 76, yeah. Median is 15 times 4 is 60. Everything should just multiply by 4 except for one thing. 13 times 4 is 42. Standard deviation, I'll grab my calculator. Notice I'm skipping the variance. Always skip the variance, all right? Never do the variance. Try to do a shortcut on variance. 26.532. Q1 should be 6 times 4, so it should be 24. Q3 is 19 times 4, so that should be 76. And IQR spread, that also works, that should be 42. So I'm going to go ahead and submit all these except for variance. And you can see I have almost everything. Oh, do I have, wait, determine the new mean. The mean was, 4 times 13. That's not it. It's 52. Pretend I can multiply, right? All right, so I'll submit those. Good thing I get a second try, right? Actually, that doesn't apply to me in this mode. So now you can see I have all the values correct. Okay, what about this variance? Well, what I'm going to do is I have to square that 26.532. So I'm going to hit squared, enter, and I get 703, see, 703.947. So I'm going to type that number in here, 703.947. It's fine to have plenty of decimals. Now, if you multiply, this is about 44, right, by 4, you're not going to get 703.947. As I said, variance is super special. It is much easier to square your standard deviation to get your variance than to try and use the rules on it. And I would tell the same thing to my AP Stats kids. So I hit submit for testing. Oh, by the way, when you're taking a test, there you go. We're all good. You can, it looks like I need a page break there. You can just copy and paste this data to your Statlet. So here I did a Control-C. Now I'm going to go to Statlet, and I'm going to go edit my inputs, and then hit delete that, hit Control-V, and voila. So I can say, oh, this is quiz scores now. This is going to be a super easy test for you guys. I hope. All right, and there are my quiz scores. So let's go ahead and see what we need to do. So they want the mode. So looking here, do we have more than one mode? We have 2 modes. We have 50. The modes you really want to get from the dot plot. Let me add that to our notes. To get modes, these are going to be super short notes. To get modes, graph the dot plot using Statlet and look for the highest totals. All right, there could be more than one. If only one mode, if 2 or more modes, and I never do more, then list in ascending order with a comma between and no space. All right. So this is just, it's not because that's like a statistics thing. This is more like an entering it in WebAssign thing, all right? So this is a WebAssign thing, not a stats thing, all right? Just so you know what's going on there. Okay, so let's go ahead and My modes, I had 2 modes. What were my 2 modes? 100, and you can float over it in case you can't read the value. So if it was over here, you could see, oh, that's 62. So I got 55 and 100. And usually on the mode, list in order. See, I say it on here, separated by a comma with no spaces. 55, comma 100. Median, let's see, the median is 69 and the mean is 72.133. Let me do the 72.133. And then we got the 69. Skip variance, always save variance for last. Standard deviation is, actually I can probably copy and paste right there. Oh, why am I typing when I could just copy and paste? Voila, look at that. And, oh, what else do I need? I also need Q1, Q3, and IQR. So this will not give me IQR, but it does give me Q1 and Q3, 55 and 85. And remember, whoop, did it just submit for me while I was in the middle of stuff? Yeah, it didn't let me put the 85 in. And then I can just subtract these two things. Don't try and make the Statlet the WebAssign do it for you. If you need to, grab a calculator. 85 minus 55 is 30. All right. So, and then we hit submit. And yeah, this probably feels very intimidating. You're like, oh, there are 57 blanks, but some of these blanks are super fast, all right? Okay, now, I still don't have the variance. So that's where the calculator comes into play. And I'm going to, let me actually see if I can squinch that down even a little more. So my standard deviation is 16.797. So I'm going to hit clear just so you don't see that. 16.797, and I just square it. I wonder if it lets me copy. No, it won't let me copy and paste that. 282.139. 282.139. All right, and then hit submit. So we can double check that variance. Variance can be a slippery sucker. All right, and there it is. Beautiful. Now, we're going to add 8 points to the quiz scores and recalculate statistics. So you could manually go and add 8 points to all these data points and then figure out the new value. But if we're adding, we could also just go 69, on the mode was 55 and 100. So now that's going to 8 plus 55 is 63 and 108. So you add to anything that is location. So that's like median, 69 plus 8 is 77. Mean, 72.133 plus 8 is 80.133. Skip variance. Actually, we can do these two. Anything of, well, let me do the positions. 55 plus 8 is 63. 85 plus 8 is 73, right? So, do you notice 73 and, I'm sorry, pretend I can add. 85 plus 8 is 93. Let's do that. So, first of all, let's make sure all our values for position are correct. And I knew I was doing position. Save spread sometimes if you're not sure. All right, so all of this is correct. Now, IQR, 93 minus 63, is that the same or different? Oh, it's the same. So that's a hint to you. Maybe you should come and do IQR first and say, did it change? No, it didn't. Guess what? That means that the other values, variance and standard deviation, stay exactly the same. I can just copy the numbers down. And that way I don't have to go add 8 to every data point and recalculate, all right? I don't have to do that. Okay. So we've got 36 out of 57. We're more than halfway through. And a teacher is teaching 2 AP statistics classes. On the final exam, the 20 students in the first class had a mean score of 92, while the 25 students in the second class had a mean score of only 83. If the teacher combines the classes, then what will the new mean final exam score be? So I'm actually going to do something real quick. Give me a second. You might see part of it. Where's the question? There it is. All right. So I'm actually making a copy of this screen. Let me go ahead and crop it. And I'm going to paste it in our Statlet so I can kind of show some work. average. There we go. So let's go to the Staplet, and we're going to give some space. So I am going to need this Staplet a little bit. There we go. Come on. So here's the problem. Now, remember, you guys may have different numbers on this. On the reviews, I'm not too worried about it, but on a test, you will have different numbers, and I have ways of making this work. So here's how we do a weighted average. The easiest thing to do, so weighted average of two groups, and that's probably what it's going to be, equals number in group 1, right, times, actually let me do an extra parentheses, number in group 1 times group 1 average plus number in group 2 times group 2 average divided by number in group 1 plus number, oh, we're supposed to still be down, plus number in group 2. All right, so what does that mean for this? So let me move this a little bit. So our weighted average, I'll call it WA. Why not? Although it looks like website, doesn't it? All right, so I'm going to take, we have 20 students in the first class times 92 plus we have 25 students in the next class times 83. Add all that up, divided by 20 plus 25. So I'm going to recommend, the most common error that comes up here is really a calculator issue. So I'm going to grab my calculator, because you might be tempted to just do things like, oh, 25 times 92 plus 25 times 83, and it's going to give you the, you're going to miss a parentheses. If you do parentheses like I did, it'll be fine, but a lot of you don't. So I would go, okay, let's do 20 times 92, right? Enter. Figure out your top things, and then the other one is 25 times 83. Just keep your math easier. This just makes life easier. All right, so I'm going to copy those two down. So I'm going to show the work here, and you might want to do that too. 1840 plus 27.5. Divide it, and I can figure out 20 plus 25 is 45. All right. So finally, when I add these two, and there we go. I should get 3915. That looks right. So 3915 divided by 45. Yeah, just work this puppy out, and then go ahead and divide it by 45. And I'm getting 87. All right, so that is, let me go ahead and put that in, 87. So in this problem, you just got to do some number crunching. It's not hard number crunching. Pretty straightforward. And then we have that right. So there we go. Okay, 3 statistics classes all took the same exam, and their distributions of scores are shown in the histograms. So there's all 3. Which class has the highest median score? I'm going to say class 3 has the highest median, right? Because the halfway point where half the data points, it's got to be class 3. For which classes are the mean and the median most different? That would be also on the most skewed class. These two are somewhat symmetric. So pick the class with the most skew, because the skew, when you stretch the data out, like you're pulling the data to the left, that is pulling the average away from the median, so, or also known as the mean. For that same class, which is higher, the mean or the median? So since this data is being pulled to the left, then the mean is being pulled to the left. So the median stays up here somewhere, and the mean is lower. So the median is higher. Why did you select the answer in the previous question? It's because the graph is, oh, not right, skewed left. Which class had the smallest standard deviation? Standard deviation is a measure of spread. I'm going to say class 1 is the most tightly clumped together. So I'm going to say class 1. All right, so let's submit that. Make sure I didn't make any goofs. And you can see they were all correct. All right, so hopefully that makes sense there. I'm not going to give you something that's going to be super hard to tell. It should be pretty straightforward. You want to get automatic admission to UT, and they accept the top 7% automatically. Although I hear that's now changed to 6%. What percentile must you be in for automatic admission? So we're going to use the 7% because that's the problem. So the top 7% means what percent are below them? It would be the 93rd, and look at RD, 93rd. So this is going to be a whole number percentile. Kaori says she's in the top quartile of her class. Does she qualify for automatic admission? So that means she's in the top 25%, but we don't know if she's in the top 7%. So I'm going to say maybe. Maybe she qualifies, because she definitely has to be. If she wasn't in the top quartile, I know she'd be below that, and she wouldn't qualify. Because her percentile may not be high enough, right? We definitely want a high percentile, but we're not sure. Ryan says he's right at the median for his class. What percentile is he in? The definition for median is the 50th percentile. In fact, let me write a note. So let's write some quick notes on that problem. Percentile is the percent of data at or below a given value or data point. And median is always at the 50th percentile. That's the definition of median. It cuts the data in half, all right? So let's go ahead and submit these. See, these aren't so bad. We're almost done. And you get a whole quiz grade for cheating off of me here. Okay, box and whisker plot. We're going to copy the data, make our life easier. So this is a generic box plot. It's not drawn to scale. What I'm going to want you to do is tell me what all these values are. So let me go ahead and copy this data, and I'm going to edit my inputs, clear them all out. All right, and I don't even know what kind of data this is. Begin analysis. All right, so there's my data, and I'm going to hit box plot. There you go. And actually, you can have a dot plot and a box plot at the same time. Did you know that? That's kind of cool. Maybe we'll leave it like that. Okay, so let's go to not counting outliers, provide the values for each of the box plots below. So point A is the width of the box. So let me go ahead and figure out these other points first. A, B, C, D, E, and F. So that's the min. That is Q1. That is the median. That is the Q3, and that's the max. So this is assuming there are no, so don't worry about outliers right now. So that could be a little tricky if we have outliers. So B, we should be having the min. So yeah, 4. Let me make sure I did that right. So I'm going to say 4 for B, and I'm going to double check that because technically it's an outlier. So to you guys, you're probably thinking, let me see. Did I ask what is this value or that value? Let's see. Let's go find out. I forgot. So I want to make sure I'm instructing you properly. Did I want the 9 or the 4 there? No, I wanted the whiskers. So I'm actually, yeah, it's like, hey, wait a second. I think I wanted you to tell me where the whiskers were. So this should be the 9. So we're actually looking at the box plot. And so that's why I said not counting outliers. So there's 9. You can actually float right over the box plot right there. That's 31.5 and 36. Let me go ahead and put those in before I forget. 31.5, 36. And then this value is 46.5 and 50. So you don't even have to remember these values. I could have pulled them from right here, except for that one. That one's special because it's not a min. It's not one of the 5-number summary. You actually have to float over it to find it. But you can just float over these values and it will tell you what it is. So we've got 46.5 and 50. Let me go ahead and put those in. And submit. There we go. Go back to question 7. So they all look good. IQR is the distance from C to E. So if I go 46.5 minus 31.5, that looks like that's 15. And then let's go look at the box plot to see how many outliers there are. There's 1 point here. Now in box plots, this could be stacked. So that's why it's nice actually to have the dot plot too. So you can see I have only one value at 4. And if I forgot, I could look at the data and I could say, huh, how many 4s are there? There's only 1 4. Okay, so there's just one outlier and it's a 4. Oops, pretend I put 4. And I'll submit that. Look, we're to this, almost to the last problem. And we got all that right. So let's 3 questions left. Select the box and whisker plot. So what I'm going to do is I'm going to copy all this data, Control C, go to Staplet. I'm not trying to test you on data entry. That's not the point of this class. That's a typing class. They used to have typing classes. Did you know that? There you go. There's my box plot. And so I got to figure out the one that looks closest to this. So this is at 5, 9, 10, 12, and 16. All right, whoops. I want to go over here. Let's look again. That looks pretty wide. They kind of scaled it down, didn't they? Makes it look weird. Okay, so I'm going to say it looks closest to this one. It says maple generated plot. I have to learn maple, apparently. Looks closest to that one because, first of all, there's some width on our whiskers. So this looks like way too skewed there. This box is too wide. Let's see. And besides, we need the beginning of the box to be about 9. So that's probably the easiest way to look at this and say, that's 9, that's 10, and that's 12. So let's go look at our choices. I think it's this one. That looks close to 9. That looks close to 10. That looks close to 12. Whereas this one's way too low on the box plot. That's way too low. Yeah, that's got to be it. IQR, interquartile range, is the width of the box plot. So it's from 9 to 12. Or you could just say Q3 minus Q1. So that should be 12 minus 9 is 3. Wyoming has a dropout rate of 7%. Into what quartile does that fall? So let's go ahead and check. 7%, that's in the first quartile. That's in the first quartile because it's way down here. Okay. And it tells between Q1 and the median, Q3 above Q3. So this would be between the median and Q3 and then above Q3. Go on. We have 100% correct, and you are done with your review. Good luck on your test.